Good afternoon, everyone. Sorry, good morning, everyone. How did the homework go? How did the worksheet go? Do you have any questions? Please get going. Okay. I'll give you a minute to get your stuff together, and please put your questions on chat and your camera on. Number 13 and 19. Okay, that's from the book, I imagine. Number 3 on the worksheet. Okay, very nice. So I will start with the book problem, and then I'll go to the worksheet problem. So we're gonna do number 13 from your book. Okay. I will graph right here the picture that it's in your book, so to be much clearer for us. And the way it works is like this. It's starting somewhere here. It's going down, up, back down. That's the graph in your book. And let's see what numbers are. Halfway through, that's 0.25. And then there is a total symmetry here. And the max here, it's a 4 and minus 4. Okay. So that's really that's the picture we have. And the question is very clearly find a formula for this trigonometric function. All right. So the formula we're looking for is, I just write them, are something of that format. Y equal A sine bt plus k, or y equal A cosine bt plus k. And the b, that's the only thing that usually you may tend to forget, that the period is 2 pi over b. A, an absolute value, is the amplitude, k is the midline. So the amplitude is the absolute value of k, and the midline is k. Okay, all right. This stretch, this shift up, and this stretch or compress horizontally, causing the period to change. All right, so that's really the formula. Okay, so now for each one of those problems, I have to ask myself, what's the A, what's the B, what's the K, is it a sine, is it a cosine, and so on and so forth. All right, so for this problem number 13, let's get going. First, what is the amplitude in this problem? Quickly, I need answers, if it's not hard. 4. The amplitude is 4. There is nothing, that's the amplitude. And the midline, so those two are easy in this problem. The midline is the line y equal to 0. All right, now what's the period in this problem? What's the period? 0.5, do you agree? The period is 1, because the period is how long it takes to finish the graph. So basically you have to imagine that the graph keeps going like this. It keeps repeating itself. So the period is going to be either from here to here, which is a 1. That's one way you can visualize the period. Or if you extend your graph a little bit, it's going to be from here to here. And this is a 1. So the period in this problem is actually equal to 1. Okay. So we basically find the amplitude, we find the midline, and now we want to find the b. How to find the b? 2 pi over b is the period. So if, like we did last time, you multiply by b across, so multiply by b, you get b is equal to 2 pi. And finally, the graph looks like, okay, looks like what? I want on bright, looks like sine, cosine, minus sine, looks like sine. Very good. Now we put the whole thing together and we have the formula. It means y equal to 4, that's the amplitude, sine of B is 2 pi t plus k, which is a 0, sorry. Okay, so that's the formula for sine 2 pi t. Means if you take this function, we graph it. You know, we take our calculator or anything, we graph it, we get exactly this picture right there. Okay. Question before I move on to your other problem, which is number 19. Okay, can I move on? Okay. Nobody say no, I'll move on. Please ask question as we work. So number 19. Okay. I will graph it and then we'll work it out. So this is the graph. And they have a midline here. The graph is going down. It's going up. It's going up again. And it's going down. And then it's going down again. Okay, so that's really my graph. And the only thing they are giving me is this point right here. Take me, this point is 9, 4. Okay, so this means that this x coordinate here is 9 and my y coordinate here is 4. All right, so that's really the picture. And they want a formula for that. And again, the formula is cosine, sine, and so on and so forth. So we have to figure out everything, and you have to help me out. First, what is the amplitude in this problem? Yeah, 2, because the amplitude, so this is the midline. The amplitude is the distance from the maximum to the midline. If this is 4, the amplitude, this is equal to 2. Now, my midline is this line right here. If this is 4, halfway through is 2. So don't really need any computation in this problem. Y equal to 2. So far, so good. Now, the period. And that's probably the hardest part in this problem. What is the period? First, let us graph. The period will go from where to where. So the graph starts here. It goes down, it goes up to here. And then the values are start to repeat themselves after that. So on the graph, the period is a cycle. It's from here to here. That's really the cycle. And then the graph is starting to repeat itself. So this is one cycle. Okay. And the question is, how much do we have from here to here? Can anybody figure the answer out for me? And this is 9. So we have to kind of remember, how is this thing split into pieces? Okay. Let me ask the following question. Does this graph look like sine minus sine? The graph looks like what? So the graph looks like minus sine. So before we figure out the period, let me take a small piece of paper and ask you the question. If you guys are not figuring out the period, let me ask you the following question. Okay, I will come back to this. Let us see how the graph of sine looks like. Even if it is the basic one, the period 2 pi. Okay, that's the graph of sine. So it peaks, it goes like this. Even the sine, don't worry about the minus sign. It goes like that. Okay, so we have to understand it. What's the value here? The basic graph of sine. What's the value here? Quickly, that's the pi. What's this here? What's this here? From here to here, those are absolutely equal to each other. It peaks at pi over 2 and at 3 pi over 2. So you can imagine 2 pi divided into 4 equal pieces. 2, 3, 4 equal pieces. The peak is happening at pi over 2. Now, let us say I have the following graph. Look like sine again, but the period, let us say it's, I don't know, it's 6, for example. I want you to fill out, tell me what should be those 2 points where the peaks is occurring. Can we figure them out? So it's basically like sine, but we're changing the period. Where is the peak is going to happen? What do you think this is going to be? So what this is just like this piece which switched a little bit. Actually, let me give you an easier one than 6. Suppose I give you pi here. It means basically I'm taking the graph of 2 pi and squeezing it. What do you think those values are going to be? How the division is going to happen? All those are basically equal. If this is pi the period, this is going to be halfway through. This is pi over 4 and etc. This is 3 pi over 2. So what I am heading toward. If my period is 6, means the graph repeats itself every 6 units. And this graph looks like sine. It means that this should be 3, halfway. This should be 1.5, 3 half. And this should be how much? 1.5, 3, 4.5. Okay, that's how the division is really happening for the sine. Okay, so the peak, so you can always imagine if this is the period look like sine, this is going to be split into 4 pieces. Now, why I am approaching that, why I am talking about this in this problem? Why am I talking about that? If this is 9, that's minus sine, but exactly now this is peaking here. Those are the pieces. So this is 1, 2, 3, 4. So if this is 9, it's going to be the 3, it's going to be 6, and that's going to be 12. That's how the sine works. So my period is going to be 12. And the cosine go like this. Over a period, you have to imagine the graph is split into 4 pieces. And the peak happened at one of those pieces. So now the period is 12. It means 2 pi over b is equal to 12, because in those problems is the b that I want. Multiply by b across would give me 2 pi equal 12 times b. So my b would be 2 pi over 12. Now we simplify, giving me pi over 6. And now the picture is complete. So my y is equal to, the graph looks like minus sign. So it's going to be, the amplitude is 2. It's 2 minus 2 sine of pi over 6 t plus 2. And that's the graph. So basically, if I actually now graph the function, it means if I take this function, actually let me do that. I'm going to take what we got, I'm going to share the screen with you, and I'm going to graph it. We should get exactly what we have. So let me try this, see if I can do that. I didn't prepare it like last time, so I will have to, okay, the program I use is Desmos graphing, okay. And I'm going to graph the function that we just found its formula. So which is going to be minus 2 sine pi over 6 times, it doesn't take t, so I have to put x in here, and plus 2. Okay, so that's really my graph here. Okay, and let's see what we got. And that's basically, so that's basically the graph. 2, that's a 3 in here. It go up to 6. is peaking at 9. That's the 9 here. This point right here is the 9, 4 that you have in the picture, going all the way down, and this is the 12, which is my period. And that's exactly what we got. Okay, so the formula we got totally coincide with the graph of the function. All right. Okay, so that takes care of that. Now I'm taking care of the problem in the book, and then I will do the problem you guys ask from the worksheet. So the last problem from the book, I have to scroll up, and it's number 27. Very good. All right, so number 27. Okay, the 27 is exactly like the worksheet. So, okay, so we're gonna do this. This is exactly like the worksheet. So I will pick it up and I will do number 27. I hope you guys read it, otherwise it will be useless. So let's see what the problem is. This is exactly 27, if my memory is correct. Okay, I'll do 27. They are basically the same, the numbers are changing. So let me look at 27. So here we have a Ferris wheel is 35 meters in diameter. So I have a Ferris wheel and it's 35 feet in diameter. So from here to here, we have 35 feet. Okay. And boarded at ground level. So we're boarding from here. That's where the boarding is. The wheel completes one full revolution every 5 minutes. So we need 5 minutes to go around the Ferris wheel. At t equal to 0, you are in the 3 o'clock position. So we are right here at t equal to 0. We are right here and we are ascending. And it takes us 5 minutes to go around the Ferris wheel. And the problem is let h of t be the height after t minutes. H of t, height above ground after t minutes. Okay. And the question is, sketch the graph of the height and find a formula for the height. Find formula for h of t, telling you that it's a sine or a cosine function. Right? So the only way I know how to do this problem is by sketching the graph of the height. Without sketching, I really don't know what's really going on. So we're going to go back to what we did earlier on in the semester and graph the height. So to graph, again, I am a bit slow. I have to find values, so I understand the problem. And then I will proceed after that. So the time are t equal to 0. What is the height? Now I want you to answer quickly. Is it 35? It's starting at the 3 o'clock position. The diameter is 35. So at t equal to 0, is it 35? Am I reading something wrong? Yeah, no, it's 17.5 because you're starting from here. They are telling you that at t equal to 0, you are at the 3 o'clock position. So that's going to be the 17.5. Okay, now, at what time? So it have a revolution, it lasts 5 minutes. So you're here at t equal to 0 and t equal to 5. Very good. Now, at what time are you up here? Okay, this. At what time you are up here? 5 minutes to go around, 2.5 to give half of 2, that's 1/4, 1.25, you are up here. So if t equal 1.25, now I am at 35. Now, I am up here halfway through the trip. So that's 2.5. So at 2.5, I am at back to 17.5. So we were oscillating. And then here I am at, you guys are faster than me. What's the t here? At what time I am here? Help me out. 1.25, 2.25, you're adding 1.25, so this put me at 3.75, so I am right here. So this is at 0 then, because that's the ground level. And then after 5 minutes, I am back to here. It means I am back to 17.5. And then we repeat. The values are going to repeat, and repeat. So these are the values. Now we're going to sketch the graph, and then we're going to come up with the right formula. Okay, so sketch the graph. So this is my 5 here. And immediately we're dividing into 4 equal pieces. That's really what's happening here. So this is my 2.5. These are, and that's my 1.5, and that's my 3.75. And now we're going to pick up the value and graph. At 0, I am at 17.5. So let us imagine this is 17.5 right here. I am right here. At 1 point, sorry, that should be 1.25. At 1.25, I am at 35, which is twice that much. So this is 35. If I erase this a little bit, so I am right here, that's 35. Okay. At 2.5, I am back here. At 3.75, I am down right here. And then at 5, I am back right here. Okay, now we're going to connect the dot. The graph looks like this. It goes like that. It goes down. And it backs up. So that's the height. And then, of course, we're going to, if we take another revolution, my graph is going to be repeating the same. So now the question is, let us find the formula that fits this graph. Very good. Now we're back to problems that we've done. So to find the formula, usually we have to find everything, amplitude, midline, draw the midline, and do the whole thing again. So let's do that quickly here. What's the amplitude in this problem? This is relatively easy in terms of amplitude. So what's the amplitude? It's half the distance. So this is 35 is the max. The mean is 0. So the amplitude is halfway. It means 35 divided by 2 is to 17.5. Because the mean, so the max here is 35 and the mean is 0. So I am halfway through them. Now the midline is, in this particular scenario, the midline is y equals 17.5. Okay, the period is 5. Now we know that we want the b. It means 2 pi over b is 5. Let's give me that 2 pi is 5b. The b is 2 pi over 5. That's give me the b. And finally, the graph. The graph looks like, that's the midline. We're starting at the midline. That's a sine graph. And now the formula. It means what's the height? A formula that fits the height is going to be equal 17.5 sine of b. It's 2 pi over 5t plus the midline 17.5. So that's a formula for the height. So now, for example, suppose I ask you, what's the height after 0.25 minutes? 0.25 minutes should be somewhere in here. If you want the height, you plug in 0.25 into the formula. So that's really the benefit. So if you want now the height at any moment in time, you just take the time and you plug it inside here, and then you get your height. So let's finalize with the problem from the worksheet. Let me look at it. And number 3 from the worksheet, and then we start the new section, right? So let's look at number 3 from the worksheet. So we have a population of animals, and it oscillates annually from a low of 1,300, so that's the low in January 1st, to a high of 2,200 on July 1st. And then back to 1,300 on the following January. So that's a population that, depending on the season, it keeps going up and down. So it's very low in January when it is cold, so its highest is in July. And we're assuming that the population is well approximated by a sine or cosine function. Otherwise, the problem wouldn't be doable. The question is, find a formula for the population as a function of time. So time is my input, and at the time p, where t represent the number of months after January 1st. And my hint for you, make a rough sketch of the population and use the sketch to find amplitude, period, and midline. Okay, so let us a little bit sketch this graph. So let's see what's really going on here. So this is time. So graphing is usually our key idea. So this is time, and this is the population. And they are telling me that the population is hovering at 1,300, that's at slowest in January. And t equal to 0 is January. So t equal to 0, that's January. In July, it is 2,200. Now, July corresponds to which months? What's t in July? February, March, April, May, June, July. So July is 7. 1, 2, 3, 4, 5, 6. Because t equal to 0 is January. All right, so you guys have 7 because you're counting January, February, March. But for them, t equal to 0 correspond to January. So t equal to 1 correspond to February, March, April, May, June, July. So this is July, t equal to 6. Okay, because 0 is February, it's January. January is not 1. Okay, and so it's picking up here all the way to 2,200. So let's assume this is 2,200. And then after that, it's going to go down. The next January is back to 1,300. So July, August, September, October, November, December, and now here t equal to 12, which is the following January, is backing up to 1,300. Okay, so these are some of the values. Okay, so the graph we expect it to be somewhere like that. So we're really doing an approximation. That's how we expect the graph to be. And then it's going to repeat. So we assume that the population is behaving exactly in the same way. Okay, so that's the picture that we're expecting. So now the question is, find a formula that will fit this population that is oscillating. And we're going to do it exactly the same way. We're going to find the amplitude, the midline. We find the period, which will allow me to find the B. And then, is it a sine, is it a cosine, and so on and so forth. So let's do that. First, what is the amplitude? So to find the amplitude, we always have to know what's the maximum value, 2,200, and the minimum, which is 1,300. Okay, so what's the amplitude? So exactly, everybody is telling me. So from here to here, the difference between them, so the difference between them is 900 here, or you can use the formula. So halfway through, we are at 450. So the amplitude is 900 divided by 2. The amplitude is 450. Okay, and this doesn't show very well. So that's the amplitude. It's 400, means from here to here. Okay. Now, what is the midline? This is the amplitude for 50. The midline is this one. That's the midline. So the midline is going to be y equal, as I said, you can use the formula I gave you before, or you can just figure it out. It's 1750. And my period. The period is what in this problem? It means how often it is repeating itself. The period is 12. So every 12 months, we're assuming that the population repeat its behavior. So now to find the formula, we need the B equal to 12. It means 2 pi equal 12 times B. It means B is 2 pi over 12. Now we simplify, we get pi over 6. Finally, the graph looks like what? Sine, cosine, be very careful. Where does the graph start? Does the graph start at the midline? No, the graph does not start at the midline. It starts at the minimum. So it's a cosine graph. Only the sine start at the midline. The cosine start above or below the midline. So it's starting quite below the midline. So that's the minus cosine graph. Finally, we have to put the whole picture together. So now what's the population? So I'm going to write P of t for the population. It means that's the population at time t is equal to minus, because the minus cosine graph. The amplitude was 450 cosine of pi over 6t plus, we're shifting, so it's a cosine graph shifted by 1750. So this is right here, that's the 1750 plus 1750. And the t here is in radian, because we're using the period to pi, which is a radian. So t is in radian. And that's important because to be answered the question, we have to make sure our calculator is in radian. So since I used the 2 pi, my t is in radian. If I had used 180, my t would be in degrees. So that's the formula for the population. So now I'm asking you, estimate the population on May 15. So now that I have an approximation of it, May 15, what is the population? Okay. How do we do that? What's t on May 15? Okay, what is t? Let's go back. 1 is February. So let me get rid of that. So 1 is February, 2 March, 3 April, 4 is May, and June. So May 15, what will be the t? Not quite 4, it's May 15. T is 4.5. Okay, and I need the population at 4.5 somewhere in here. Okay, so it's going to be the population. So that's really what it is. Means I need to find the population. Right, so let's do that. The only way to do it is I have to plug it back into the formula. So it means I need the population at 4.5. So I plug in 4.5 for t. I will get minus 450 cosine pi over 6 times 4.5 plus 1750. Okay, now I have to compute this. So it's equal to minus 450 cosine. My calculator is in radian, so I can, if you want, evaluate the inside, which is gonna give me how much? It means 4.5 pi over 6 plus 1750. So this is equal to what? Okay, let us compute that. So it's minus 450 times. What's the cosine of that? So first I have to make sure my calculator is in the right mode, which is I don't know because I'm switching since I'm teaching in this class. So, so radian, I have to put in radian mode. And then I need the cosine of 4.5 pi, sorry, cosine 4.5 times pi divided by 6. And this is giving me minus 0.7071. So this is minus 0.7071 plus 1750. So now I have to multiply this answer by minus 450. And then I add 1750 to it. I'm getting 2068. So that's 2000. Since I'm talking about population, I'm going to drop the decimal after that. Exactly. So we get 2068. It means after in May 15, so the population was 1300. In May 15, the population grew to 2068 people. Okay. Now, see. On what date will the animal population be halfway between the max and the mean? Now the picture may be a little bit here confusing, but who can guess? When will the population be halfway between the max and the mean? If you remember the graph of cosine very well, when this should occur, when the half should occur here. So I'm gonna a little bit erase this to see if you guys can answer this question. Right, it should create, so if this is the period, right? This is 12 from here to here. So how much should we have from here to here? Yes, but 3 units. From here to here, 3. From here to here, 3. And from here to here, 3. Okay, that's how it works. So if this from here to here, 3, so that should be March 1st. Right, so that should be March. So this picture here down here, because I don't have great scale, that's why I'm erasing. So this should be, my apology for that, but I need to do this. So this should be 3, 1, 2, 3. So this could be March 1st. And then right here. So it's July. So I want this right here. So I'm going to erase to get that a better, absolutely, to be more and more accurate. So I have July, August, September, and that's going to be October. So it's going to be March and October. Okay, so the only way to do that, just like remember the picture as I was talking about the sign, go back to the midline, and that should be split into 4 equal pieces. So the population halfway would be March 1st and October 1st. Okay, so that's how we think about this problem. So crucial to understand that the midline intersect the graph and splitting it into 4 equal pieces in a way. That's the picture here, and that's the graph for the function. All right. Any other questions? Very good. Today, in the time we left, I'm going to start section 7. Whatever this is. 7.6, and we're going to start talking about the tangent function. So I will start it today. So there are a lot of trigonometric functions. The sine and cosine. Wait. Okay, wait, I'll wait. What is it? And the weight is, she's absolutely correct. February, March, April. Yes. Wait, no, you're not confused. I am wrong. You're not confused. This should be April. Thank you very much. Anybody else? Okay, thank you very much, Kathleen. Thanks. All right. Very good. So now we're moving to whatever section is 7.6, tangent function. So that's another trigonometric function, and this is, again, it has its own section because sine, cosine, and tangent are the most important one, even though we're going to learn all the others, but this is important. All right, so the tangent function. So what is the tangent function? Okay, so far we talked about the sine, we talked about the cosine. And before I talk about the tangent, I want to talk a little bit more about the cosine. And so let us remember the cosine for a reason in my mind. Graphically, what's the cosine? You start the unit circle and you take a point here. Angle is t. And the cosine is the x-coordinate of t, of the point P. That's the cosine. And we graphed it. And the graph was like this. Means we start asking, okay, if t is 0, what's the value of the cosine? It is 1. And as we move toward pi over 2, the cosine is actually, the x component is getting less. So the cosine is going like that, backing up like this. That's at 2 pi. And then it repeats itself from both sides. Okay. And those points, as I was emphasizing a minute ago, that's the pi. That's the pi over 2. That's the 2 pi. And just out of curiosity, what's this point here? What's this point right here? Quickly. And what's this point right here? And what's this point? If I keep going like that, repeating my graph. Okay, what do you think this point is here? Minus pi over 2. What's this point here? Minus pi. What's this point now? This point, what's this point here? This one here. 3 pi over 2. What's this point here? And there is a reason I'm asking this question. What's this point here? I'm not asking you just for the sake of it. What's this point right here? That's 2 pi. And now we're adding pi over 2 to it. So if we have 2 pi and we add pi over 2 to it, what do we get? A common denominator will tell me 5 pi over 2. That's 5 pi over 2. And we keep going. This point would be, that's 5 pi over 2, 6 pi over 2, 7 pi over 2, and so on and so forth. Now, suppose I ask you the following question. Find all values of t such that cosine of t is equal to 0. So basically, I'm going to ask you, when does the cosine takes the value 0? Okay, what will be the answer? Okay. When is the cosine takes the value 0? We can answer this question either by looking at the unit circle, or we can answer the question by looking at the graph. All right, so I'm getting answers. So the students are telling me at pi over 2, because the x-coordinate is 0, or now from the graph, because once you memorize the graph, you can start answering those questions as well. So at pi over 2. Also, 3 pi over 2. Are those the only values where the cosine takes the value 0, or there are more of them? You know, the cosine makes sense everywhere. There are tons of them. Every time you add 2 pi, you get it. So then we have the 5 pi over 2, 7 pi over 2, like odd powers of pi over 2. Then I think the picture now 9 pi over 2. And I think now the idea is a little bit clear. But I can add more. Is pi over 2 plus or minus? Because it's 0 at pi over 2. It is 0 at minus pi over 2, because on right here, this is minus pi over 2. That's minus pi over 2. And the x-coordinate here is absolutely 0. So when I'm thinking, so minus 3 pi over 2, it means right there. Also, the x-coordinate is 0. So here I can put plus or minus, plus or minus, plus or minus, plus or minus. So the cosine is 0 for infinitely many values. So this is on the unit circle. On the graph, you can see them. Pi over 2, 3 pi over 2, 5 pi over 2, minus pi over 2, minus 3 pi over 2. Okay, so and that's important to see, to understand the cosine on the unit circle, and at the same time to see it as a graph. Okay. Now, why I'm bringing this up? First, because we have to know it, and then it's relevant the minute we're going to talk about the tangent. So let us define the tangent. What is the tangent function? So tangent, definition. Okay, first on the unit circle, and then later we graph it. Today we don't have time to graph. Suppose I take, that's the unit circle. That's a 1. And here I am. And that's an angle T. T could be everywhere. Then the tangent, and that's the point P that corresponds to the angle T. So this is X, Y. Then tangent T. That's so tangent of T that we abbreviated as TAN T is defined to be the sine of the angle divided by the cosine of the angle. So the tangent is defined to be the sine divided by the cosine. On the unit circle, the sine is the y-coordinate. That's the sine. And the cosine is the x-coordinate. So this is going to be defined, the y-coordinate of the point, that's the unit circle definition, divided by the x-coordinate. Okay, tangent of an angle is to be the sine over the cosine, which is going to be the one we will use the most. And on the unit circle also, it's the y-coordinate, so it's the y over the x. So that's the 0, it's the y over the x. The y could be positive, the y could be negative, anything you want. So let us just practice a little bit the definition today, and next time we will graph it and so on and so forth. So basic one, what is tangent of 0? Absolutely based on our definition. So what's the tangent of 0? Definition is the sine of 0 over the cosine of 0. Okay. Now, what's the sine of 0? Do you guys, have memorized this? Uh-oh, the other way around. Okay, give me a second. Okay, what's the sine of 0? The sine is the y-coordinate. It's the 0. The cosine is 1. Tangent 0 is equal to 0. Okay. Now what's tangent pi over 6? It's the sine of pi over 6 over the cosine pi over 6, okay, which is equal to what? Now, anybody remember the sine of pi over 6? I wish I had face-to-face because you guys will have to totally memorize those. That's a half. The cosine is the square root of 3 over 2. Now we simplify this. It's a half times 2 over the square root of 3. So the 2 and so this is 2 over 2 square root of 3. It means the tangent of pi over 6 is going to be equal 1 over the square root of 3. Okay, so this is really what the tangent are. Let's see one more. And this one is good because this one usually is easy. What's the tangent of pi over 4? Remember, the tangent means you're taking the unit circle. That's what you're doing. You're taking the angle pi over 4. And you're finding the sine over the cosine. Okay, this is equal to what quickly? Remember, that's pi over 4. That's the y, and that's the x. The angle is pi over 4. What's the y over x is what? Okay, anybody with me? Over, which is equal to 1. So tangent pi over 4 is equal to 1. Okay, so I'm going to stop right here. I will assign homework for tomorrow. And before you start the quiz, I know some of you couldn't wait. Exam number 1, please listen carefully. Your first exam is next Wednesday. Is on Wednesday. Next Wednesday, which is, I don't know the date, at 7. So it should be February 17. Okay. Review, you will have a review. It will be on Bright Space, hopefully by tomorrow evening. Okay. Tangent will be on your exam. So do the small homework I'm going to assign to you, and I will do more homework on Monday. Okay. Start your quiz.